Okay, today we're going to be talking about domain and range. The domain is your x values. Sometimes we call these the inputs because it's what we input into the function. Okay, your range is what you call your y values. We call these the outputs because when you input an x value, you get an output or you get a y value. So let's look at this a little bit more. So here's a graph with 5 or 6 different points on it. So what we're going to do is we're going to find the domain and the range from all these points. But to do this, we have to be able to name the points. So if you look at the first one right here, you have -3, 1, because it's left 3 up 1. The x value, remember, is the first point, so -3 goes in your domain, and the 1 goes in your range, because that's your y value. This point right here is -1, -1, because it's left 1, down 1. So -1 is in your domain, and -1 is in your range. Over here we went right 1 up 2, so 1, 2. So that means 1 is in your domain, 2 is in your range. Underneath that you have 1, 1. Now here we come to a point where 1 is already in our domain, so we don't need to rewrite it. And 1 is already in our range, so again we don't need to rewrite that one. Over here we have 2, 2. We need 2 in the domain. We already have 2 in the range, so we don't need to rewrite it. And the last one we have is 3, 0, because it's right 3 and then we didn't go up or down. So we need to put 3 into our domain, 0 into our range, and then we put our brackets around it, and that's our domain and range. Let's look at another one. Here we have a mapping diagram. The domain is the inputs or the x values. The range is the y values. So if you look, they actually already have it listed. So your domain is -3, -2, -1, 4, and 5. Don't forget your squiggly brackets. Your range is 2, 1, 0, and 4. Mapping diagrams are much easier than the graphs. Okay, and then you can also do the domain and range from a set of points. Remember, your points are x, y. So the first number goes in your domain, 0, -3, and then if you look, we have another 0 right here. We don't need to rewrite that, so 0, -3 is your domain. Your range is 2. Now again, we have another 2, so we don't need to repeat, and then we have a 5. So your range is 2 and 5. Alright, now moving on, we have the range. We want to find the range of the function f of x equals 2x minus 1. So we need to underline that, make sure we know we're using 2x minus 1. And then they give us the domain, -3, 1, and 2. If you remember, the domain is your x values. So what we're going to do is plug each x value in for this x right here and figure out what that is. So we have 2x minus 1. We're going to do it 3 different times, once with -3, once with with 1, and once with 2. So we have 2 times -3 minus 1. Now if you have a calculator, you can go ahead and plug that in. 2 times -3 is -6, minus 1 is -7. I suggest plugging in your calculator all at once so you don't make any mistakes. Then we can plug in the 1, so 2 times 1 minus 1. 2 times 1 is 2, minus 1 is 1. And then we have 2 times 2 minus 1. Notice how the only thing changes in each of these equations is the x value. Everything else is the same the entire time. 2 times 2 is 4, minus 1 is 3. So your range, which is what they asked for, is -7, 1, and 3. We always put our domain and range back into our squiggly brackets. Alright, let's do another one. Find the range of f of x when we have the function -4x plus 1 for the domain of -3, -2, 0, and 5. So now we're going to have to do this one 4 times. Each of these numbers is going to be plugged in for x. So we have -4 times -3 plus 1. -4 times -3 is 12, plus 1 is 13. We have -4 times -2 plus 1. -4 times -2 is 8, plus 1 is 9. negative 4 times 0 plus 1. Negative 4 times 0 is 0, plus 1 is 1. And then we have negative 4 times 5 plus 1. Negative 4 times 5 is negative 20, plus 1 is negative 19. So if you look, your domain, or excuse me, your range, which is what we're trying to find because they give us the domain, is 13, 9, 1, and negative 19. All right, last one. Find the range of f of x when the function is 1/3 x plus 2 for the domain negative 3, 4, 6, and 7. Now I know what you're thinking. You're thinking there's a fraction, but you got to remember 1 over 3 is really just 1 divided by 3. Fractions are just dividing, so we got to remember that. So let's plug these in. 1 over 3 times negative 3 plus 2. 1 over 3 times negative 3 is 1 divided by 3 times negative 3, or 1 times negative 3 divided by 3, which is negative 1, plus 2 is 1. Then you times it by 4. So 1 over 3 times 4 plus 2. This is where we leave a fraction, which is okay. 1 over 3 times 4 is actually 4 over 3 plus 2. But remember, when we add fractions, we need common denominators. So this 2 is over 1. So to make these the same, we'd have to multiply top and bottom by 3. So this is really 4 over 3 plus 6 over 3, which is 10 over 3. We can add and subtract and multiply and divide fractions. All right, next one. 1 over 3 times 6 plus 2. This is the same thing as 6 divided by 3, which is 2, plus 2 is 4. And then last one, 1 over 3 times 7 plus 2. Well, you gotta remember 1 over 3 times 7 is 7 over 3 plus 2. Now if you look back right here, 2 became 6 over 3, so we have 7 over 3 plus 6 over 3, which is 13 over 3. Okay, so our domain is negative 3, negative 4, 6, and 7. But our range, I'm going to put it right in here, where I have a little room, is 1, 10 over 3, 4, and 13 over 3. And then we're done. Okay, so just to remind you, domain is the x values, and range is the y values.